Welcome back, everyone, to today's Explainer. We're jumping right into something that is literally the heartbeat of your industrial operations: predictive maintenance. Now, you already know it's absolutely crucial to keep that heavy machinery running safely. But today, we aren't just reading from the standard playbook. We're going to shine a light on a massive, potentially devastating blind spot in how a lot of facilities are protecting their assets. So I want you to really think about this for a second. Is your current predictive maintenance setup totally missing the biggest threat to your facility? It's kind of a heavy question, right? For decades, the industry standard has leaned heavily on one specific technology to predict failure. But what if that tech is completely blind to the one catastrophic event that could shut down your entire operation overnight? Yeah, we're talking about a fatal gap in fire protection.
Section 1, the Predictive Maintenance Standard. Okay, let's dive into this by acknowledging the undisputed heavyweight champion of the current standard, vibration monitoring.
Look, I want to be crystal clear right out of the gate. Traditional vibration monitoring is genuinely impressive technology. Vibration analysis is excellent at diagnosing mechanical faults in rotating equipment. That is just a fact. If you're running a refinery that's packed wall-to-wall with pumps, compressors, and turbines, vibration monitoring is absolutely your go-to. You slap a sensor on a motor, you measure those vibration patterns, and the system tells you exactly what's wrong. Bearing defects, shaft misalignments, rotor imbalances, it spots them long before a failure happens. For that specific job, it works perfectly.
Section 2, the dangerous blind spot. But here's the thing. Most facilities aren't just a collection of pumps and compressors.
If you're operating a sawmill, a planer mill, or recycling plant, or frankly any facility handling combustible dust, you face severe fire risks. And this is exactly where we hit that dangerous blind spot, because mechanical vibration sensors completely miss this risk. Think about the stark contrast between these technologies. Vibration sensors measure mechanical motion. They need one-to-one physical contact, and they only work on rotating machinery. Thermal monitoring, on the other hand, measures heat. It provides zone-wide coverage, and it covers non-rotating and electrical equipment too. A vibration sensor literally cannot detect a smoldering ember in the dust extraction system. It won't spot a stuck board causing friction or an electrical panel that's about to arc. Why? Because fire isn't a vibration problem, it's a heat problem. Section 3. Zone coverage versus contact sensors. This brings us to the real logistical and financial burden of traditional sensors. I want you to visualize your factory floor for a minute. Picture the dust, the moisture, the heavy machinery moving around, the sheer massive scale of the whole shebang. 50. If you want to monitor 50 individual assets using traditional vibration methods, you need 50 individual sensors. Think about that. That's 50 fragile sensors physically bolted onto the machinery. 50 sensors that have to be wired up, connected, configured, and constantly maintained in an environment that is just punishing. Heavy sawdust, moisture, intense physical vibration, cables get damaged, wireless connections drop. It is a massive, expensive logistical headache. And this brilliantly illustrates the power of shifting our perspective. 1. A single continuous AVIAN thermal camera monitors an entire production zone. Every single motor, bearing, belt, roller, duct, and electrical connection within its field of view, covered by just one device. You're effectively replacing dozens of fragile physical contact points with a single overarching eye that monitors the actual temperature of your entire operation.
So what does this actually mean for cost efficiency and durability? Well, thermal cameras are mounted high up on a wall or ceiling, completely out of the way. There's zero physical contact with your vibrating, moving equipment. You aren't running a maze of cables across the production floor where they can get tripped over or, worse, run over by a forklift. And honestly, the best part for wood processors, a ceiling-mounted camera cannot get buried under a giant pile of sawdust. It's incredibly resilient simply because it's up and out of the danger zone.
Section 4. Case study: the smoldering ember. Let's get out of the theory for a second and anchor this in reality. We're going to walk through a real-world scenario from a customer site where a planer mill faced absolute ruin. This timeline perfectly captures how terrifyingly fast industrial fires can spread. Step 1. A board gets stuck on the planer, and it starts creating immense friction. Instantly, the thermal camera detects a rapid temperature spike to 100 degrees Celsius. Step 2. That friction spawns a glowing ember, and the dust extraction system violently sucks that ember right up into the ductwork. Step 3. Just an hour later, a completely separate thermal camera 50 meters away catches a really subtle heat signature on the ceiling. The AI flags it at just 75 degrees.
Step 4, disaster averted. Within a minute of that alert, the outside of that metal duct was hitting 115 degrees. But because the system caught it early at 75, the operator shut the whole thing down before the duct hit a critical point.
As the customer bluntly put it, without your system, we would have had a disaster. A planer mill can lose way more from a single fire than from a decade of normal equipment failures combined. And here's the absolute kicker. No vibration sensor on Earth would have caught this. Why? Because vibration sensors don't measure the friction heat of a stuck board, and they definitely don't measure the temperature of a sealing duct. They would have just sat there, silently monitoring the motor's vibration while the entire building burned down around them.
Now, if you've been around the industry for a while, you might actually be wondering this right now. But isn't thermal a late-stage indicator? It's a super common pushback, especially from the vibration monitoring crowd. The thinking goes that heat is just a symptom of a failure that's already happening. So if you're waiting for something to get hot, you're already too late.
Actually, if we were talking about a guy walking around the factory floor once a month with a handheld FLIR camera, that pushback would be 100% right. You'd only be catching problems that were basically already on fire. But continuous AI thermal monitoring completely shatters that outdated assumption. It shifts detection from a reactive once-a-month check to a proactive, real-time prevention strategy. Here's the mechanical truth of how AI thermal catches failure so early. A modern system measures temperatures 25 times per second. That's lightning fast. And it's analyzing every single pixel against a massive database of historical baselines for that specific machine. It's not waiting for a bearing to hit 200 degrees. It instantly detects a tiny 5-degree deviation. And this is a real game changer. That subtle temperature increase from friction actually shows up days, sometimes even weeks, before the vibration signature changes enough to be measurable. So thermal isn't late at all. In this continuous AI format, it's actually incredibly early.
Section 5. One sensor, two solutions.
Okay, let's bring this all together and look at the ultimate business case here, because you really don't need two entirely separate, incredibly expensive infrastructure projects to protect a combustible environment. When you compare the capabilities side by side, the ROI becomes incredibly obvious. Predictive maintenance, both vibration sensors and thermal monitoring check that box. They both tell you when a motor or a bearing is starting to degrade. But what about zone-wide coverage? Vibration is a hard no, while thermal is a definitive yes. And fire prevention? Vibration gives you absolutely nothing, zero. Thermal monitoring, though, is built specifically to catch it. With thermal, you're tackling bearing degradation and fire prevention simultaneously, and you're doing it with a fraction of the hardware. As we start to wrap up this explainer, I want you to mentally assess your own facility. Do you process combustible materials, like wood or recycling? Do you have crucial non-rotating equipment, things like electrical panels, hydraulic systems, or ductwork that need monitoring? Are you bleeding budget trying to instrument hundreds of individual assets one by one? And honestly, do you have a dangerous blind spot when the facility is unattended after hours? If you're nodding yes to these, relying solely on traditional vibration monitoring is leaving your operation dangerously exposed. So I'll leave you with this final provocative thought. Your equipment fails in heat, and your catastrophic fires start with heat. Doesn't it make perfect sense that your primary sensor should measure heat? Thank you so much for joining me for this explainer. It's time to rethink those blind spots, protect your operations, and as always, never stop learning. Catch you next time.